Fundamental theorem of calculus, yay, we can do fun stuff now. There are two parts to the fundamental theorem of calculus. The first one, some books call it part one, some books call this part two, so don't be surprised. I think the Math is Power for You video switches them. So there are two parts. Doesn't really matter which one you call part one. We're going to call this part one. That says if you take the derivative with respect to x of an integral from a to x of a function, then the function comes out. So part one tells you that integration and differentiation undo one another. Part two tells you that we can use antiderivatives to calculate definite integrals. Now we're definitely going to put a little more onto those, but that's just a quick overview of what's coming. Hopefully you did your prepare sheet. And this is more about area under a curve, so we're back to that same trapezoid. We calculated the area of the trapezoid using the formula for the area of a trapezoid. And then we used the same formula, area of a trapezoid, to find a function f of t, which is the area under the curve from t equals 1 to t equals x. So I'm going to go ahead and write that down. So this is number 2 on your sheet. So my area, and I'm going to use the same h and b1 and b2 that I did before. So my h is this distance right here, but instead of a 4, I'm thinking of this as being x. So my height is x minus 1. Then my bases, well, base number 1 stays the same. I can just plug 1 in. It's equal to 5. Base number 2 would be equal to 2x plus 3, wherever you get the height when you plug x in. Hopefully you did this already, but I'm going to go through it anyway. So I'm going to combine like terms. I still have x minus 1 over 2. I have 5 plus 3, which is 8, plus 2x, which is x minus 1 over 2. I'm going to factor a 2 out of that second binomial there, and I'll have 4 plus x. That way I can cancel and not have a fraction. And then I'll do first, outer, inner, last. Actually, I'm going to do outer first because I want x squared to be my first term. And then, let's see, first gives me 4x, last gives me minus x. And then inners gives me minus 4. Doesn't matter what order you do it in, you're going to end up with x squared plus 3x minus 4. So that would be my area function that tells me the area from 1 to x of this function underneath 2t plus 3. So I'm going to call that 2t plus 3 dt, because that's the area under the curve from 1 to x of 2t plus 3. There's my function. Now, what do I get if I take the derivative of that? That was your question on the back there. So the derivative of my area function would be 2x plus 3. Look. Those are exactly the same. differentiation and integration undo one another. Now, the book went through it in example 1. I'll leave that for you to go through on your own if you want to. They found the area of all the rectangles, and then they sketched a graph of what would be the derivative. But here is the official blue box, Fundamental Theorem of Calculus, Part 1. So, like I said, we need to add a little to what I have written down here. F needs to be continuous from A to B. And G is the function that is the area under the curve from A to X. The derivative of that thing is equal to the integrand. Differentiation, integration, undo one another. So roughly speaking, it says we get that we first integrate F, then differentiate the result, we get the original function back. Example 2 is super easy. One of the easiest problems you'll have. It asks to find the derivative of the function. So I'm looking for the derivative with respect to x of the integral from 0 to x of the square root of 1 plus t squared dt. Now, I don't know the antiderivative or how to integrate square root of 1 plus t squared, but since I'm taking the derivative of the integral, all I have to do is replace that t with an x squared. Easy peasy. Now, students often say, hey, but what about that 0? If you plug that 0 in, you'd get the square root of 1 in there. But no, if you plug the 0 in, you're going to get a constant. And what's the derivative of a constant? 0. So, yeah, it works. You may ask, why in the world would you want to do such a thing? Example 3 just gives you a real-life application where they actually do define a function of the form, the integral from a to x of f of t. It's called the Fresnel function. But let's look at some examples. Fundamental Theorem of Calculus, Part 1. We're asked to find the derivative of these strangely defined functions. So g primed of x is going to be equal to, well, I just have the integral from 1 to x, so a constant to x, of natural log of 1 plus t squared. All I have to do is replace the t with an x. Easy peasy. Number 12. This time I'm going to manipulate it a little bit because r of y is equal to the integral from y to 2 t cubed sine of t dt. I want it to look exactly like that Fundamental Theorem of Calculus, Part 1, and that has the number at the bottom, the constant, and the variable at the top. So thank goodness we learned those properties of integrals, because this is equal to the negative of the integral from 2 to y of t cubed sine t dt. So the derivative of y is equal to the negative of the derivative of this function. Now let's go ahead and put negative. No, we won't. So it's equal to the negative of the derivative with respect to y, not x, because we want y's in it. integral from 2 to y t cubed sine of t dt, which is negative y cubed sine of y. Voila. Now, number 14, a little bit different. We don't have a plain old variable involved in h of x. We have the square root of x. And inside we're using z's because these are just dummy variables and we can use whatever dummy variable we want to. So first thing you do is think about the chain rule. If you're taking the derivative of a function, which is exactly what we're doing. We're taking the derivative of this function, 1 to x, and we're taking the derivative of the square root of x. So h primed is going to be equal to, plug this into your original function, so the derivative of the outside function, and the integral is your outside function, the square root of x squared, square root of x to the 4th plus 1, times the derivative of the inside function. And I'm going to simplify this one. Of course, I would never expect you to. You could leave it just like that. Square root of x squared is x. Square root of x to the 4th is x squared plus 1. And down below, I also have a 2, and I have an x to the 1/2 power. Now I have an x to the 1/2 down below. I have an x up top, so I can make this x to the 1/2 on top of x squared plus 1 times 2. You can leave it like that. Important part is don't forget the chain rule. So if you have just a plain old variable there, plug it in, plug it in. If you have a function of a variable, plug in the function, then multiply by the derivative of the function. Chain, chain, chain rule. That is Fundamental Theorem of Calculus Part 1.